All right, class, this is number 27. I know in first hour we didn't have enough time to go over this problem. Maybe we did in seventh hour, but even if we did have time to go over it, I think it's still a good thing to put it on here. So we have 3 points, and again, since we have 3 points, we can put them anywhere in space. This is 0, 0, 0. This is 1, 2, 3. And this point here is negative 2, 3, 3. So as it turns out, these 3 points represent, obviously they're a triangle, but they also represent a plane. And if you still have questions on how this represents a plane, just ask me tomorrow in class, or hopefully I covered it in the 7th hour. All right, so these represent a plane. It turns out to find a plane, all you need is 1 point, and then what's called the normal vector. Well, a normal vector is a vector that is orthogonal to the plane. So there's that word again. Orthogonal means it's 90 degrees away, a difference than the plane. So basically what we're going to do is we just need a vector that points straight away from this thing. So if this plane is the screen, the vector would be coming straight at you. So to do this, to find a normal vector, we just need to cross u with v. Okay, because when we cross u with v, the right-hand rule says if I start going down with my fingers down the u and I cross it towards the v, I curl them towards the v, my thumb represents the cross product, and that actually turns out to be the normal vector of this plane. Okay, so the equation for a vector, or for a plane, is a x minus x1 plus b y minus y1 plus z minus z1. I'll put that below it. C z minus z1 equals 0. So I ran out of room again. Okay, this is the equation of a plane where a, b, and c are the normal vector. So in our problem, it's going to be the cross product of u with v, a, b, c. And x1, y1, z1 is one of these 3 points. And obviously we're going to choose this point because it's so much easier to work with than these other 2. All right. So to do this problem, we need to take u cross v. So I, j, k, u would be the vector from this point, 0, 0, 0, to this point, negative 2, 3, 3. Since we're using 0, 0, 0, the vector that goes from here to here is just that point. So negative 2, 3, 3. And then the other vector would be the vector that goes from 0, 0, 0 to 1, 2, 3. So 1 minus 0, 2 minus 0, 3 minus 0, 1, 2, 3. Alright, so I, negative j, k, 3 times 3 is 9, minus 6, 3. Negative 2 times 3 is negative 6, minus 3 more is negative 9. And negative 2 times 2 is negative 4, minus 3 is negative 7. So my A is 3, my B is 9, my C is negative 7. And now I can throw them into this equation here. A is 3, x minus x1. B is 9, y minus y1. C is negative 7, z minus z1. And this is 0, this is 0, this is 0. So I just get 3x plus 9y minus 7z equals 0. So that, let me double check to make sure. Okay, this is my answer. The back of the book has this as the answer. Okay, who's right? Well, it turns out we both are. Both of these are normal vectors. They just go in the opposite directions. So, and all you need to define a plane is a normal vector. So there's obviously going to be two normal vectors to a plane, one going up and one going down. So on the test, you could have either of these two answers would work. Okay? And also, I chose to use this point here. Another student may choose to use this point and have this as x1, this as y1, this as z1, and you're going to get another different answer. So there's an infinite amount of ways to display or to give the equation of a plane. This is one way. This would be another way, and then I could change all these x1s and y1s because there's infinite amount of points in a plane, and each of those points would work in the equation of a plane. So this is number 27.